how to analyze, how to interpret X-ray fluorescence spectra. This is the XRF spectrum for gold wedding ring. If we look into this graph, there are two pieces of information. One is on y-axis, and that is basically the intensity. The intensity of the X-ray fluorescence, not the intensity of the incident X-ray. Another piece of information is available on x-axis. This is basically called the X-ray energy in kilo electron volt. This is again the energy of the X-ray fluorescence, not the incident X-ray. Because we know that in XRF, we bombard X-ray on the sample. And because of that bombardment, the core electron eject from the sample. When the core electron eject from the sample, from the atom, so now there is a probability that the higher shell electron will jump to this shell. And when the electron jump from higher shell to the lower shell, there is an emission of photon. And that photon is exactly in the form of X-ray. And this is we call XRF, X-ray fluorescence. Now, this information on the x-axis, this is the X-ray energy, the X-ray fluorescence energy, basically just like the fingerprint, because it reveals, it identifies which element exists in the sample, which element present in the sample. So this information is basically talk about the qualitative information. Qualitative, which element is present? Okay, copper is present, gold is present, silver is present, zinc is present. Yeah, it is fine. It is not going into detail, but it only reveal which element is present. The second important information is on the y-axis, and that is basically the intensity. So this talk about the concentration. So, okay, fine. We identify from the x-axis that there are 1, 2, 3, 4 elements exist. Now, what is the concentration of these elements? Which elements exist in small proportion? Which element exists in large proportion? So the intensity basically talk about that. So this intensity y-axis is basically talk about the quantitative analysis, the chemical concentration. What is the percentage of the copper? 50%. What is the percentage of the gold? 40% or something like that. Now here we have K alpha here with this copper. Here we have again K alpha, K beta. Here we have L lines. Let's discuss how these lines appear, in why they appear. So we know that in X-ray fluorescence, we simply bombard X-ray on the sample. This is the atom, right? And we know that let's suppose there are 4 shell in this atom. One is the K shell, L shell, M shell, N shell. Now let's talk about how X-ray fluorescence works. So we know that in XRF, we simply bombard X-ray on the samples. So when we bombard, when we shine X-ray on the samples, so the core electron eject from the atom. When the core electron eject, so there is a vacancy. Now this vacancy has to fill by other electrons because electron want to become stable. So now from the L shell, there is a probability to fill this vacancy. So when electron jump from the L shell to the K shell, so there is a emission of photon, and that photon is basically in the form of X-ray, and that line we call K alpha here. Very simple. Now there is a probability that electron may jump from this M shell to the K shell, and that is we call K beta here, K beta X-ray. Right? Now there is a probability that this incident X-ray may create vacancy in the L shell. So if this electron is ejected, so there will be vacancy here. Now that vacancy has to fill by the higher energy shells electrons. This means from M or from N. So when the M shell electron fill this vacancy, that is we call L alpha. When the N shell electron fill, that is we call L beta. This is how we see these L beta, K alpha, K beta with copper, with zinc, etc. This is how XRF work. And here we use X-ray because the penetration power of X-ray is more powerful and more higher than the electron. Because this technique is similar to the EDX, which we use in SEM analysis. The same technique we use just like the SRF, but in EDX we use electron. So this EDX is basically used with SEM, and that is basically the surface analysis. Now you want to see deeper. For that purpose we use XRF. Now, how to interpret this? Very clear. You have to talk about the two things, the y-axis and the x-axis. This is how you have to explain. So we know that in gold wedding ring, maybe there are some traces elements because we cannot make jewelry from pure gold. So I don't know about the copper. They may use the copper, they may use the zinc here, they may use the gold, they may use the silver, etc., to make it ductile or to make it into shapes, etc. So in this XRF graphs, the author basically compare three soil samples, and they basically added similar concentrations of manganese, copper, and zinc. So we can see that in all three graphs, we have the similar iron K alpha peak here. So this means that the soil contain iron. So iron is here, iron is here, iron is here. The manganese peak, the copper peak, the zinc peaks are also available, but interestingly, the manganese peak is very low as compared to the copper and zincs. So there may be some other reasons, but one reason is the manganese atomic number is less than the copper and zinc. We can see here in periodic table, this is the manganese here. So this means that it has lower atomic number than the copper and zincs. Yesterday I put quiz on the YouTube community, and in that quiz I asked this question, that if the atomic number increases, so what happened to the fluorescence peak intensity? And the fluorescence peak intensity shoot ups, and this is how we can see here. This manganese has low atomic number, so the intensity is lower. But copper is more atomic number, so intensity is higher, and zinc has the highest peak intensity because we can see here that zinc has higher atomic number than the copper. There is also another important thing. For example, there is overlapping in the peak. And when there is overlapping in the peak, so maybe this iron peak get the contribution from this manganese peak. And how to know that contribution? For example, this contribution can be explained with this technique that is basically called the wavelength dispersio XRF, because with energy dispersio XRF we cannot distinguish that overlapping contribution. But with the help of wavelength dispersio XRF, we can distinguish. I will make separate video on these two techniques of the XRF. This is the paper I took the data from. This is the title of the paper by Leo Sharp and 2024 under the license C4.0.